In Chapter 2, we had seen that in this data set, it looked like there was a linear relationship between a student's height and their shoe size. So we're going to just explore those two variables again with some of the things we've learned about relating to regression in Chapter 9. First of all, let's do a quick look at the graph, that scatter plot, because we do know for checking conditions the scatter plot is important anyway. So we go to simple scatter and scatter dot here, click define, put our two variables in. So height is our x variable that would help us predict shoe size, which is our y variable. Click OK, and our scatter plot will pop up here. And we're looking to see if we have a linear relationship, and then also that the variability looks to be about the same for our trend as we move left or right from our x's, and that we have no major outliers. So we do see a linear relationship. The variability is about the same. We maybe have a little less variability here, but we also have fewer data values, so we don't want to read too much into that. So it seems to be pretty consistent from left to right. And these are maybe kind of a little bit of outliers, but they're not super serious. So all of those things appear to check out here. So when we want to fit our linear model, we go to Analyze, Regression, Linear, and we did this in Chapter 2. We're just going to point out some different details today. So we're going to put in height as our independent, our x variable. Shoe size is our y variable. We also can go over to save the residuals if we want, and those will be added to our data set. You can also click on plots here and say that you want a normal probability plot, and that will let us quickly check if our residuals look normal. So that's a quick check of that. So click continue, click OK. Okay, so we have the model summary box. In the model summary box, we did talk about in Chapter 2 that r is our correlation. R squared, right next to it, 0.729 is our r squared value. One other detail we have in this box is the standard error of the estimate is our S sub epsilon that we talked about in 9.2. We've talked about our ANOVA box now, so if you would take the SS regression of 200.794 and divide by the SS total of 275.621, that will give you this r squared of 0.729. We have an F test statistic of 171, a p-value of 0, so we can see that the model is effective. In the coefficients box, we have our intercept and slope under the B. We also have their standard errors, so the standard error of the slope here is 0.030. A couple columns over, we have our t-test statistics, so our t for testing for slope is 13.105 with a p-value of 0. So we would find that we have a significant linear relationship in the population between height and shoe size. And then at the bottom here we have this normal probability plot of our residuals, and we can see that they do follow pretty closely to the line, suggesting that that assumption of normal residuals is also met. And the other three things we checked earlier in our scatter plot. So that is a little bit about some of the new things we've talked about in Chapter 9 and how you can find those things in SPSS.